Welcome back to Summarize Science, where we break down the latest in tech research. Think about the complex motion you see every day, from a person walking to an excavator digging at a construction site. These aren't just single, simple movements. They're made up of many smaller parts all working together in a specific structure or hierarchy. Traditionally, animators and programmers had to manually define this structure, telling the computer that a hand moves with the arm and the arm moves with the shoulder. This works, but it's time-consuming and doesn't easily adapt to new or unusual objects. This paper introduces a new system called HEIR, which can learn these complex motion hierarchies automatically just by watching things move. The core idea is to represent all the moving points in a scene as a graph. The AI's job is to figure out the parent-child relationships between these points. Essentially, it learns that a child point's motion is just its parent's motion plus a little bit of its own unique, local movement. To test this, the researchers first created a simple 1D experiment with points moving in nested sine waves. This created a clear 3-layer hierarchy of motion. As you can see from the diagram, the HEIR system was able to perfectly reconstruct this hidden structure from the raw motion data alone. Next, they tried it on a more intuitive 2D rotational problem, a synthetic planetary system. Without any prior knowledge of physics, the AI watched the points move and correctly inferred that moons orbit planets and planets orbit the central star. It successfully learned the nested orbital relationships, showing it can handle more than just simple back-and-forth motion. But the most impressive demonstration is with complex, dynamic 3D scenes. Here, they applied the method to scenes made of thousands of 3D points, like this excavator and a person doing jumping jacks. They then tested how the scene reacts when a user interactively moves a single part, comparing their method to a previous state-of-the-art approach. The results are striking. When moving the excavator's shovel, their method maintains the rigid structure of the machine's arm, creating a realistic motion. In contrast, the other method introduces unnatural bending, making the machine look like it's made of rubber. You see the same improvement with the human models, where HEIR produces physically plausible limb movements, while the other method creates distorted, unrealistic poses. And these visual improvements are backed by hard numbers. Across 4 different test scenes, their method consistently outperformed the baseline on several image quality and similarity metrics. This confirms that the deformations are not just prettier, but also structurally more faithful to the original scene. So, let's recap the key points. Researchers created an AI that can discover the hidden parent-child structure within any complex motion without being explicitly told what the rules are. This learned hierarchy allows for far more realistic and controllable animations and deformations of 3D objects. In the future, technology like this could lead to smarter, more intuitive animation tools for artists and game developers. It could even help robots better understand and interact with complex, articulated objects in the real world. Thanks for watching, and be sure to subscribe to Summarize Science for more breakdowns of cutting-edge research.